Good morning, students. Today we're going to learn about how to write chemical formula of a compound. Here we are going to talk only about the ionic compounds. So in this video you're going to learn about this and you will come to know that how to write this chemical formula and what is the reason behind to write that way. So let's start this video to understand how to write the chemical formula of a compound which is in the ionic state. Okay, here we go. Suppose we have the to know this, we should have to clear about the word called valency. Valency means the atom. Suppose you have a sodium atom. So valency of the sodium atom is depends on how many electrons it can donate or accept. So we know that sodium valency is 1 because it can donate 1 electron. Similarly, we know the chlorine atom has or bromine even have the valency 1, but it's negative valency. We say that why we say negative, because it accepts that negative charged electrons. So this is how we use the valency concepts to write the chemical formula of a compound. So I hope you remember the valencies of that. If you don't remember, don't worry, you can go out, check it out, their atomic number or electronic configuration. You can easily figure out how to do it. So let's start exactly the sodium and bromine, or sodium and chlorine. I think that it is the more simplest one. So we know that the sodium valency is 1. Now sodium valency is 1 and that valency is shown by this arrow. So it can donate the electrons, that's why I'm showing you with these arrow sign. Okay, this is arrow over here, which you can see this is the valency of it is 1 arrow, so it means its valency is 1. Now what happens, the valency is 1 and chlorine, its valency is -1, so it accepts that electron. So arrow was fired, was released from the sodium, and that is going to fit into this vacuum, which you can see that. And then this is how you get these to mingle together and form the sodium chloride. So one sodium valency, 1 its valency, and finally you get the formula of sodium chloride as NaCl, something like that. Together we write NaCl. We don't write this negative charge, because they get neutralized with each other. Now we move to the next. Let me show you more complicated one, how to write them. NaCl. Suppose I want to write a magnesium chloride formula. Okay, now magnesium chloride, we know that magnesium's valency, the magnesium have the valency as a 2. Okay, magnesium have the valency 2, which you can see behind it, because its electronic configuration is 282. Okay, so this is what these two arrows showing, that its valency is 2. To satisfy the magnesium chloride I want to write, so what I need here is chlorine. Okay, but chlorine valency is 1, as you can see that. Okay, so it's 1 valency, but we have here the magnesium's valency is 2. Now we cannot just put 1 chlorine with the 1 magnesium to get a magnesium chloride, because it's still unsatisfied at the one other end. Okay, it wants to donate 1 more electron, so we need 1 more chlorine. We need 1 more chlorine to satisfy that, because chlorine has a 1 valency. So it comes along this way, and okay, so it gets attached something like this. Now 1 magnesium required a 2 chlorine. So you can see that what is happening, you have a 1 magnesium and you have 1 chlorine, and magnesium's valency is 1 and chlorine valency is magnesium valency is 2 and chlorine valency is 1. And what happened, this magnesium needs 2 chlorine to satisfy, and this is what happens, you need to do what is called the crisscross. So this 1 will goes to magnesium, and valency of magnesium will transfer to chlorine this way. So finally you will write the formula as Mg. Now this one will reach with this, and Cl, okay, Cl with the 2. So this is how it looks, MgCl2. But we don't write 1 because magnesium itself is showing is one atom, so we don't have to write this one. So it looks like this one, MgCl2. Now the question comes again, you might be thinking about this minus sign. This minus sign we don't need actually when we're writing in this format. So magnesium required 2 chlorine. I hope you're clear, because the valencies. Now let's figure out the next example. I will show you the more examples so that when your concepts in your brain should get clear. Suppose you have the aluminum. Now aluminium valency is 3. Aluminium valency is 3, okay, and aluminum valency is 3. So it means how many chlorine you required, which valency is 1. Now 1 is there, but it will not satisfy. These still 2s are left. So how more chlorines are required? In fact, when you say chlorines, it means the chloride here, the chloride ion, chlorine ions, and that you will get another one, but still is left. You need 3 chlorines because of the 3 1s here. So 1 1 and 1 more is left, so we need 1 more chloride ion to satisfy this aluminum. And this is how its formula will become. Aluminium is 1 time and chlorine is 3 times. So its formula, you can say that aluminium chloride will look like this, AlCl3, AlCl3. This is how it looks, okay. And if I want to write this one, AlCl3, how it looks, so it's something like this. Let me put it in this format. So your aluminum chloride, AlCl3, this is the molecular formula of aluminium chloride. So aluminium is 1 time and 3 time chlorine, because the aluminium has valency 3, and that 3 valency is transfers to the chlorine with the crisscross method. Let me show you how it happens. So aluminium is 3, okay, aluminium is valency is 3 and chlorine is 1, and then what happens, this cross way, you have to do it cross. So aluminium 1 valency will transfer to aluminium, this one, and this 3 valencies of chlorine, that number will transfer to the aluminum, to chloride ions like this, okay, something like this. And finally when it transfers, then we get something like this, aluminium chloride. I hope you're getting clear with the concepts. So aluminium 1, chloride ion 3 is aluminium's valency transfers to chlorine, and aluminium and the chlorine's valency transfers to aluminium. So this is how we write. Let's move to the more examples and let's see that what is happening with them. So aluminium is done. Now let's have the more I'm fed up with the 1 valency of the chloride ions and all. So let's see that if I have in case the sulfate ion or sulfate radicals, okay, this is a sulfate SO4. Now you can see that there are the two spots where chlorine sulfate can take up, because it's atomic, you can say valency is 2 here, okay, its valency is 2 here, so it takes up the 2 electrons to satisfy itself, or maybe donate those 2 electrons extra. It is a habit, okay. And we need to satisfy, if I have the sodium, then we need 2 sodiums. Can you see that? We need 2 sodiums. So I don't want sodium here. Suppose I take up the magnesium, then what is the formula? I'll get it here. Now magnesium's valency is 2 and aluminium's valency is also 2, okay. So if I write that magnesium and sulfate 1, okay, if I write the sulfate 1 here, what I'll get here, okay, what I'll get here, these 2 get reacted and they form like this, magnesium sulfate. Now 2 and 2 valencies here, so you cannot write magnesium to aluminium, because after doing that, like suppose you have a magnesium and sulfate here and its valency is 2, and now you just crisscross that. If you crisscross this one, then also you will see it, they get that 2 and 2. And if you transfer that this two to with this, it seems like it becomes something like Mg2CaSO4 but we cannot write like that. We cannot write like that. Okay, we have to write in the simplest ratio. Okay, we need to write in the simplest ratio. So if you divide these two with the 2, you will get a simple formula, MgSO4. This is the final formula of magnesium sulfate. Okay, so it looks like this way, MgSO4. So magnesium 1, sulfate 1. You need just 1 and 1 to make it magnesium sulfate. I hope you are getting clearer and understanding what is happening with these transformations and how to transfer and to get the formula magnesium sulfate. Babu mat karo Arjun. Are? Okay, now one of my students asked how to write the how we can find out the chemical formula for aluminum nitride. Now let's find out. It's very simple. So we need aluminum. Okay, so I have taken the aluminum, and now I need, which is a valency 3. Now I want nitrogen, and surprisingly and good thing is that nitrogen's valency is also 3. So as you can see that you need just one aluminum and you need just one nitrogen to get a formula. So something like this. So formula is very simple. You supposed to know, or you have to know, the valency of these two. So valency of aluminum is 3 and nitrogen is also 3. So that is why it's a good thing that aluminum nitride is just ALN. This is the aluminum nitride formula which you get. You can see that aluminum nitride. You don't have to change anything. Okay, so let's take another example. Now let's take another example of sodium hydroxides. Now I need a sodium. So sodium, we know that its valency is 1, so with a 1 arrow. And hydroxides, it's a good thing that hydroxides valency is also 1. Now these two have the same valencies. So if you write down their names with their formula, okay, like that, which you have now, and their valencies are 1, and another valence is also, hydroxide valency is also a 1. So what happens? You just allow them react and they form a compound which name is just sodium hydroxide, NaOH. Right now, NaOH. Their valence is 1, 1. And if you want to see that how to do it in the crisscross method, then you have a sodium, okay, and you have the hydroxides, okay, and their valencies are 1 and 1. As you can see, we have written the valencies here. And what will happen, then we have to put the crisscross way. We have to put these hydroxide valency number, not valency, in fact just a number, valency number we will transfer to the opposite one, okay, and the sodium's valency will transfer to the hydroxide to hydroxides, okay, something like this. And this is how you get. Now what are you getting here? The one sodium and one hydroxide only, so you get the sodium hydroxides. And this is how we get the formula which you see, sodium hydroxide, NaOH. So, and we don't have to put the, I've already discussed that we don't have to put Na1OH, 1 something, because they are already 1 radicals are there. So you just combine them, you get the hydroxide, sodium hydroxide formula. I hope you are clear with how to write the chemical formula. And if you have any doubt, you can ask me. You can write in the comment box. And if you like this one, please write yes, I have understood. Okay.